Okay, a 10,450 Newton shark is supported by a rope attached to a 4.9 meter rod that can pivot at the base. So, I marked, I marked this as the rod because that was the first part where I struggled. Was like, not struggled, but it, I really messed. I didn't know which distance would be the rod. So this is the rod, this is the rope, this is a shark. In case, I don't know what else that could be. Okay, so calculate the tension in the cable between the rod and the wall, assuming the cable is holding the system in the position shown in the figure. So, we're talking about torque, like torque diagrams, and then obviously the component of torque is like force and radius, so, or like distance. So, here's our little torque diagram. I'll get to that later. Just look at this. Here's our positive directions. This is the tension from the rope. So I just did torque of tension. I don't know if that's right, but, or I guess this would be like torque from the rope. And then this would be torque, not from, it would be torque from the shark. But since this is a tension force, and I later called it a tension force, I just did torque of tension and torque of gravity because those are like the forces on it, but it should be torque of like the rope and torque of a shark. So obviously since nothing is moving, the net torque is going to be 0 in any and all directions. So I did the vertical torque is 0 Newton meters, and I did like the tension for, obviously, okay, torque is just F cross R, so it's just F cross R, and you have to do the sine of theta because it's just a component of the tension. And then, no, you do, sorry, you do it because this is 4.9, and you need to find the distance from the 4.9. So this is, you have to do the sine of theta because the triangle, I'll make it a different color. The triangle is this, and like you're trying to find the distance. It's about this corner, and you're trying to find this distance because that 4.9 is the rod. It's the distance from the rod, and that's gonna be your R. So it's not because of the components of this torque. It's because of the like just the orientation of it. So it is kind of partially due to the fact that this is on an angle, but you have to do it to this one as well because it's because of this angle, not because of this one. Sorry, I just realized that. Okay. So then anyways, you solve for force of tension and you get 5310 newtons. Then you have to find the horizontal force exerted on the base by the rod. So then that is why I have all this other stuff in the corner. It's because of the horizontal force exerted on the base of the rod. Instead of just making it one normal force, I just made it into its components because that's what we talk about, and I didn't want to make it more difficult on myself. So, like I said, nothing is moving. If the torques are balanced, the forces are balanced. Everything is 0. So, the normal force, which is just this, is going to be equal to the horizontal component of this would be the force of tension now. And then this is cosine. You have this angle because of the components now, not because it's about this rod. So then you just have 5310, which is just that, cosine of 20, and it's 20 because this is our triangle right here. And then you get 4990 newtons. And then find the vertical force exerted on the base of the rod. Ignore the weight of the rod. So, hold on. So now, again, it's just, we're finding this one. And then everything is balanced. We're doing forces, so it's, this is going upwards, this is going upwards, and then this one's going downwards. So it's just, and since we want to solve for this one, I just put it by itself. So it's going to be the gravity from the shark minus the the tension, and then you get 86.90 or 86.40. And then this, okay. Also, this is an angle because, again, it's just the components of this force, not because of the rod stuff. So I would say, and I forgot about it when I was doing this. The trickiest stuff was like figuring out what was going on here initially, and then also why I had to do these angles here, because I thought it was just for the components. But it's not for the components. It's also because of the, like, where you're talking like about this corner instead of like somewhere else. So yeah, that's how I solve this problem.